All right, Hornets, let's investigate the graph of a log function a little bit more in depth. We'll do that here in section 5.6, and we'll investigate the domain, the range, end behavior, asymptote, and the x-intercept. And then we'll look a little bit about moving that graph up and down and left and right, and seeing how we do that, trying to recall the same way we did that with parabolas. So, let's take a look at this first graph. This is just the graph of log base 2 of x. And simply look at that domain. Again, knowing stuff about the domain, that does not cross that y-axis there because there's an asymptote. So our domain, simply the furthest left it goes is 0. Furthest right it goes will be infinity. The range, the lowest it goes is negative infinity. And this will eventually reach up to positive infinity. So as we look at this, as x goes out to infinity, the f of x, the graph itself, will go up to positive infinity. Our x-intercept, right there, should be at 1, 0, and the vertical asymptote is on the y-axis there, going through the x-axis at 0. Okay, so it's kind of a little review. So all functions have this general shape. Changing the base only changes the steepness of the curve and make it either go up here or go down there. That's not for us to worry about at this time. So on the graph above here, what we're going to do is make a guess about what happens, knowing all the things we've looked at before with parabolas, with exponentials, on how we move things up and down or left and right. So this is inside the parentheses. So again, remember, we think opposite, and it's going to affect the x. So should be able to make a guess that this does go to the left 4. So let's give this a try and take a look at Desmos, and let's graph that to see if our guess is right. That would end up taking this equation here, would just take this function here and move it to the left 4, and being drawn over here now. So let's go to Desmos, and we'd have y equals log. So we're going to press our functions, and we should be able to look at different functions in here. So there's log base a, so we can change that to log base 2. And again, in our equation, we're going log base 2 of x plus 4. So parentheses x plus 4. Finish off that parentheses. And lo and behold, it does look like it's been moved to the left 4. It was over here at 1 where the x-intercept was. So that goes back 1, 2, 3, 4 to the left. And our x-intercept is now at negative 3, 0 rather than 1, 0. So we give a little quick sketch of that. Again, this would cross, this move normally crosses at 1 right there, so we're going to move it back 1, 2, 3, 4, and it would come in roughly like that. So it would also move the asymptote, which is now was at x equals 0, move that back 4 places. So our asymptote would be right there on the x equals negative 4. So, filling this out, domain, the furthest left it goes is now negative 4. Furthest right it goes is infinity. The range still goes down to negative infinity and up to positive infinity. Now as x goes out to infinity, the graph itself, f of x, goes up to infinity. Our x-intercept is now at negative 3, 0, and the vertical asymptote here is at x equals negative 4. Okay. So just kind of little notes here. When you think about parabolas, x squared, remember when it's inside parentheses, we think opposite, and this would move it to the left 4. This again would move it to the left 4. Or when we look at radicals, inside radicals is like parentheses. Again, it's going to affect the x. Think opposite. this 2 would go left 4. Or when we did exponentials, my suggestion was always put that in little parentheses. It's up by the x, affecting it, think opposite. So again, that moves it left 4. So the same thing that we just checked here would also move it left 4. It's inside the parentheses by the x. So let's try another one. This one here, now that's not inside the parentheses by the x, so it's not going to affect the x. It's going to affect it up and down because it's not in parentheses. We think of it as is. So my guess is that it would take that original logarithm function and move it down 6. So let's give that a try on Desmos and see what happens. So this is log base 2. We can just go back and just delete this and then have minus 6 and see what happens with the graph. And if we need to here, we can actually move this graph a little bit to see that. And we can see that the original place it crossed the x-axis is right here at 1. It's now moved it down 1, 2, 3, 4, 5, 6. And here's our graph for that. So we can see here the original one crosses at 1. It's down at 2, 4, 6. That's where it's crossing. And it's going to be up there like that. Our domain, we didn't move it left or right, so the domain, the furthest left it goes is 0. Furthest right it goes is infinity. Range, it goes all the way down to negative infinity. Still all the way up to positive infinity. As the x goes out to infinity, this graph will eventually go up to infinity as well. Vertical asymptote remains still at x equals 0. And now it says, I didn't ask about the x-intercept of this graph, but what point in the graph corresponds to the x-intercept of f of x equals log base of 2? Well, as I was saying, originally it was right there. The minus 6 has had us move it down 6 places. So that point there corresponds to that x-intercept. That point is now not 1, 0, it's now 1, negative 6. So, again, think back to quadratics. Again, it wasn't 1 parentheses. This moved it down 6, moved the parabola down 6. Again, it wasn't inside the radical, so it moved that graph down 6. The exponential growth, again, moved it down 6, and we saw the same thing here as well. Alright, one more here. So, we look at two different variations of f of x equals log base 3 of x. So the red one is the original log base 3 of x. You can see all it did was just that base just changes that slant of that logarithm. So it's a little bit tighter down here now. So when I look at there's dotted, which is the green one. The dashed is the blue one there. All right. So what I've done here, if I look at the red one to the green one, looks like I just moved that up. And I'm going to start here with that original x-intercept. And it looks like I moved it up 2, 4. Doesn't look like I moved it left or right at all. So when I look at that red to the green dotted one, that graph is the same with a vertical shift of, looks like again, 4 units. So I'm moving it up 4 units. So I think that equation then would be log base 3, because I didn't move it right or left. I don't worry about putting the same thing inside the parentheses. And then I'm just going to go up 4. The dashed one, though it does look like I moved it to the right 2. It doesn't look like I moved it up or down at all. I just moved it to the right 2 right there. So again, move it to the left or right. We're going to put it in the parentheses, but as the opposite. So this graph is the same as the original graph, the red one, with a horizontal shift of, it looks like again, 2 units that I moved according to the scale. So writing that equation, I'd say it's log base 3, and because I moved it left or right, or moved it horizontally, I'm going to put it in the parentheses, but as its opposite. Okay, a little summary here. Log functions all have the general shape. They all have this same general shape as you see with these three up here. And just like all the other functions we've started so far this year, we have different adjustments to this. So when I look at this part right here, that's going to affect how I move it right or left. But because it's in parentheses, I think opposite. So this again, we'll move it right or left. And this one right here, we'll move it up or down. And it's not in parentheses, so it does it as it is. So this one here, the way it's represented, this would have a horizontal shift of positive h units and a vertical shift of k units. So very similar to all the previous graphs we've looked at, be it parabolas, be it radicals, be it exponentials. The same idea. So good luck in your homework, and we'll see you in the next section.